This time, we are going to solve for the image and pre-image of two vectors here, given this linear transformation defined by a matrix. We would know which vectors do we use as to solve the pre-image and image as soon as we are going to examine this given matrix. This is a 2 by 3 matrix. In short, in terms of m by n matrix, this is m is 2, n is 3. The linear transformation that we can draw here follows this certain pattern. We have here r to the power of n to r m. And since n is 3, we have here r3 to r2. This would mean that our vector v here with 3 components is a part or an element of our domain. So in short, we are going to solve for its image, which is part of the codomain. Our vector w here is in R2. In short, we are going to solve for its pre-image, a certain vector v with 3 components. To do that, we are going to use this specific form of linear transformation defined by a matrix. The transformation of vector v is equal to the product of matrix A and v. So our v here again is a element of R3. So this is an element of R3. In short, we're going to solve for its image. The image of vector v follows this pattern. We have 1, 2, negative 1, 1, 0, 1, which is our matrix itself. And we would know that our process is correct, including this, whether this is correct, by plotting here our vector v, which is 5, 2, and 2. With this, we can see that the product here is defined as we have 3 what do you call this one entries here that we will multiply to the corresponding 3. If we are going to use here say for example this one, the product is no longer defined, hence there's something wrong in the process, hence this is again correct now. So the image of vector v is the result of this, so it is actually the product. Of course, our image is an element of R2, just like this one here, so we expect a 2 by 1 matrix. So we have here 1 times 5 is 5, 2 times 2 is 4, 1 times negative 2 is negative 2. So 5 plus 4, that's 9, minus 2, we have here 7. Next, we have 1 times 5 is 5, that's 0, this is 2, we also have here 7. This vector of 7, 7 is the image of vector v. Okay, this is the image of vector v. And again, we see this is an element of R2, and that's correct. Now, for the pre-image of our vector w, we're still going to use the same process here. But more specifically, we are no longer solving for the result, but we are solving for this. And we know that our v here is an element of R3. Hence, our v here has 3 components, v sub 1, v sub 2, and v sub 3. This would be equal to our certain w, which is this one here. So we will have here this matrix, 1, 2, negative 1, 1, 0, 1, times again our certain vector, v sub 1, v sub 2, v sub 3. We're going to solve for the components here, equal to our vector w, which is, that's 4 and 2. Okay? So once we multiply that, we will have equations here. So 1 times v sub 1 is v sub 1. 2 times v sub 2 is plus 2 v sub 2. Okay? And then we will have here negative 1 times v sub 2 is minus v sub 3. Okay? This would be here. This is still a 1 entry. 1 times v sub 1 is v sub 1 plus 0 v sub 2. And our v sub 3 here is plus 1 v sub 3. This is equal to our w, which is 4 and 2. So our two equations would be this. V sub 1 plus 2 v sub 2 minus v sub 3 is equal to 4. And v sub 1 plus v sub 3 is equal to 2. Notice here that we don't have a specific given, so for example, we have two variables here and we have three variables equal to a certain constant. So what we could do here is actually, we're going to let v sub 3 be an arbitrary constant t. This would mean our v sub 1 now, using this equation, v sub 1 plus v sub 3 is equal to 2. V sub 1 plus t is equal to 2. So v sub 1 is 2 minus t. Okay? So what we're looking for is now our v sub 2 using this equation. So you have v sub 1 plus 2 v sub 2 minus v sub 3 is 4. Our v sub 1 is 2 minus t plus 2 v sub 2 minus our v sub 3 is also t, equal to 4. So with this, we have 2 v sub 2 plus 2 minus 2t is equal to 4. 2 v sub 2 is equal to 2 plus 2t. Okay? Or simply, yeah, that's 2 plus 2t. Dividing both sides by 2, v sub 2 is 1 plus t. In short, our this is now the pre-image of our vector w. Is a component, is a v, vector v with three components, v sub 1 being 2 minus t, our v sub 2 is 1 plus t, and our v sub 3 which is t. But of course, this is very vague in nature, so let's just make it in the form of a set. We have 2 minus t, 1 plus t, and t. Set of all vectors with this form such that t is an element of R. This is now the pre-image W, meaning there are infinitely many possibilities to get an image of 4 and 2, which is our given W. This is how we solve for the image and pre-image of our linear transformation that is defined by a certain matrix. Thank you very much for watching.